Okay, this video is going to look at kinetic molecular theory, so we're actually going to turn to this last tab, and this whole thing is going to be about kinetic molecular theory. So let's take a look at that. So kinetic molecular theory, what is it? So we abbreviate it KMT, which stands for kinetic molecular theory, and it's a theory that relates to the behavior of particles in a gas. So we're only talking about gases here. It has 5 what we call postulates or assumptions, so basically 5 pieces that we are looking at. So the first question in your tab book asks, what is KMT? KMT is kinetic molecular theory, and it's a theory that relates to the behavior of gas particles. So let's look at that first assumption. So gases have a very low density and a large volume. So low density, large volume, because their particles are far apart. So there are distance between those particles. They are not touching. How does this relate to compression? So these 2 thinking questions are not on your foldable, but I did just want to talk about them. So if you think about solids, liquids, and gases, a gas is the only state of matter that is compressible, meaning that we can make it take up less space. We could reduce the volume, or we could make it take up more space. We could increase the volume. You cannot do that for liquids and solids. They have a fixed volume. So that's something that's unique about a gas. And that comes from the fact that those particles are not in direct contact with each other consistently. Talk about our second assumption here. We're talking about collisions. So the collisions of gas particles with each other and with the walls, so both hitting particle to particle and hitting whatever the outside of the container is, are elastic. So when we have an elastic collision, that means that particles do not have dissipated energy after the collision, meaning they get to keep all of their energy. So if you've had physical science or physics and you've talked about that energy loss of a system, in theory, gas particles are not losing that energy. For that purpose, that means that all of that moving energy is still present. So the kinetic energy, again, in theory, does not change. Gas particles move in straight lines rapidly and constantly. So moving in straight lines, once it hits something and it bounces off, it moves in a straight line until it hits something else. So it will change direction, but that general motion will remain the same. Number 4, gas particles are not attracted to each other. So gas particles have such a little mass that their attractiveness to each other is very little. They do not feel as though they need to be in contact like a liquid or a solid does. So unlike liquids and solids, gas particles are not consistently touching each other. And you'll see that in a particle diagram when we draw those out, because the particles will not be touching. They will be separated for a gas. Then the last one here, as the temperature of a gas increases, and we'll talk here in a few minutes that that's the speed of the particles, temperature, the kinetic energy in the system increases. The same thing is true if the temperature of a gas decreases, the kinetic energy decreases. If 2 gases were at the same temperature, generally we can assume that they have similar kinetic energies. Okay, that temperature should be pretty consistent across both samples of gas, so their kinetic energy should be consistent across both samples of gas. So that was a quick look at kinetic molecular theory, which again is that far right tab on your tab book. And if you need to go back and pause the video so you can fill in those blanks, feel free to do so.